to see the mix of experience of people in terms of how they've used correlational research designs. I really do hope that everyone, no matter what your experience level, will find value in today's materials. So let's get started with our discussions today. Today's session will consist of two segments. In segment one, we'll provide a brief review about the links between research questions, research design, and statistics, as we've done in the prior webinars. We'll also explore key concepts, strengths, and limitations of correlation coefficients. In segment two, we'll go back and use our case study approach. And in this one, we'll explore the application of correlational research designs. As we wrap up our final webinar, we'll explore other statistical procedures that explore relationships between variables and discuss the type of questions for which these statistics would be used. As we've done in the other webinars, we'll stop for questions after each segment. So let's start our review. And as we go back into webinar one, let's review and discuss what is research. By definition, research must be systematic, logical, empirical, and replicable. The scientific method applies basic procedures and principles and allows you to move through the process of answering questions and pursuing knowledge by collecting data and testing hypotheses. When done well, this process is extremely valuable, but it certainly is time-consuming. In webinar one, we also talked about another key concept, which is, while research is in the name of institutional research, we certainly don't conduct research studies on a daily basis.
Wait a minute.
Yeah, we're having a little problem.
Yeah, I'm so sorry, it's not advancing. Robinson, could you help us out? You click again.
I am working.
Okay.
Thank you.
Well, hang on, folks. We'll get back. We'll get back on track in a minute here.
I know we haven't, actually haven't started the webinar. Thank you, everyone.
Yeah, thanks for your patience, folks. Always have some technical glitch that happens. So in webinar one, we talked about the idea that research is in the name of institutional research, yet we certainly don't conduct research on a daily basis. And the reason for that is not all questions and problems need research. And also, we don't want to force everything to require full research designs or complex statistical analyses. If we did, then we're not allowing the institution to move forward and make decisions. We really would create paralysis by analysis because we can't move forward because we're too busy running repeated, complicated analyses. But what we must understand is when is good enough? And what level of analysis is appropriate for the questions that we're facing. But when we do conduct research in IR, it's categorized as applied research. Applied research is conducted to answer specific questions about our institutions and our students. And the results are being applied directly to our colleges and universities. Remember the important concept that we've emphasized in each of these webinars. The research question drives the design, and the design creates the structure of the study, which in turn guides the analysis of the data. Thus, the institutional question is posed. A research study is designed and developed to answer that question. Next data are collected, analyzed, and interpreted, and the results are used to inform the decision. That's applied research. Before we provide another example of this process with a case study, let's review more about research designs. Remember, we need different research designs to answer different research questions. In webinars 1 and 2, we described 3 different types of correlational research designs: descriptive, comparative, and correlational. Broadly stated, descriptive research designs are used to describe the current state of affairs with regard to a given topic. Comparative research designs employ statistical procedures such as t-tests and analysis of variance to make comparisons between pre-existing groups. And today, we'll talk more about correlational research designs, which are used to examine the relationships that can logically exist between variables. It really is important that IR professionals have the ability to explore the relationship between variables. For examples, in student success models, we might want to explore variables related to a student's academic record, or we might want to explore relationships between the levels of student engagement and students' academic success. Often these types of research designs expand from measuring the relationships to creating predictive models. With that knowledge, we can use that information to better serve our students. So let's dig deeper into correlation. Correlation coefficients are used to measure the relationships that exist between two variables. These coefficients provide us with key information about the extent of the relationships between two or more variables. Let's discuss some key concepts, strengths and weaknesses about coefficients before we explore our case study. Correlation is considered to be a bivariate statistic because it measures the relationship between two variables. Correlation is often considered to be both a descriptive and an inferential statistic. It's descriptive because it describes the relationship between two variables, but it also is an inferential statistic since it can be used to test the significance of that relationship. Let's explore some of my favorite classic examples of interesting correlations that measure relationships, for example, between anxiety and performance on an examination, salary and the stress of employees. Of course, one of my personal favorites, the weight of an individual and their amount of low back pain. In these classic examples, notice that all variables are continuous in nature, and the researcher is not examining differences between groups or levels. To measure these relationships, a correlation coefficient is calculated. Correlation coefficients range in value from negative 1.0 to positive 1.0. The strength of the coefficient is indicated by the absolute value of the coefficient. The closer the value is to 1.0, either positive or negative, the stronger or more linear the relationship. The closer the value is to 0, the weaker or more nonlinear the relationship. So how does that work? Well, if we display the total variance or total variability of a variable with a circle, and we display the relationship or shared variability between two variables with two circles, then when the correlation coefficient is 0, the variables x and y do not share any common variability. Thus, the circles do not overlap at all. But when the correlation is moderate, ranging in value from 0.3 to 0.4, either positive or negative, then the variables do share common variance. Thus, our circles would overlap to a moderate extent. And when the correlation is strong, with a coefficient ranging from 0.70 to 0.80, either positive or negative, then the variables share a lot of common variance. And thus our circles overlap to a great extent. So that's the strength of the relationship. The direction of the relationship is indicated by the sign of the correlation coefficient. A positive coefficient indicates that as one variable increases, so does the other. A negative correlation coefficient indicates that as one variable increases, the other variable decreases. Let's look at a couple of my favorite classic correlations to illustrate positive and negative relationships. First, the classic positive relationship is a relationship between the outside temperature and beer sales. Of course, as it gets hotter, I, like others, enjoy a cold beer. so sales rise. And for the classic negative relationship, let's look at the relationship between temperature and hot coffee sales. As it gets warmer, the less hot coffee people will drink. And while I relate more to the beer sales, I can definitely see this trend as well. As you can see in these examples, some variables create a negative relationship, which are a function of that relationship as described. In other cases, you find negative relationships because of how the variables are scored. For example, time will create a negative relationship with most other variables, since as you do something faster, the time is shorter, and generally, that's considered to be better or more efficient. And when correlated with other variables, where higher values represent a better performance, it creates a negative relationship because of the difference in the way those data are scored or measured. Other times, the rationale for a negative relationship is less clear, or could be caused by some other spurious relationship. So let's talk a little bit about some limitations of the correlation statistic. And while correlation is a useful descriptive and inferential stat, it has limitations. First and foremost, the correlation can't be used to measure differences or causality. Correlation only measures relationships or association. In other words, the researcher does not control other influencing or confounding factors. And the researcher does not manipulate or examine differences as would be done in a true or quasi or comparative research design. Consider the case where you have two variables. Let's say student satisfaction with their program as denoted by the X variable, and student success, or GPA, as denoted by Y. Here you find a moderate correlation, which tells us that as student satisfaction with their program increases, so does their GPA, a positive finding. But let's say that you calculate the correlation coefficient between academic preparation in the form of SAT and ACT score, denoted by Z, and GPA, and you find that there's an even stronger relationship. And in addition, you also find that academic preparation is also highly related with student satisfaction. It's really tempting to say that academic preparation causes a high GPA or program satisfaction, but you can't. You might think that this limitation minimizes the usefulness of the correlation coefficient, since you can't imply cause and effect. But in general, IR is not concerned with defining causes. In this case, finding a strong relationship between academic preparation and GPA would really reinforce that academic preparation is important for student success and that we need to support underprepared students who come to our institutions. And this goes back to our lesson about remembering to not allow perfect to be the enemy of the good, or as Confucius is attributed to have stated, better a diamond with a flaw than a pebble without. So the next thing you need to know is that correlation coefficients measure a linear relationship. As we said earlier, the correlation coefficient measures how closely aligned are the two variables. So a correlation of 1.0 indicates a perfect linear relationship between the two variables, meaning as one variable increases, the other increases by an exact linear relationship. On the other hand, a zero correlation does not indicate that no relationship exists, but it does indicate that no linear relationship exists. So let's explore that a little bit more, because a curvilinear relationship could still exist. For example, in the scatter plot, we see that no linear relationship exists, and in fact, no relationship whatsoever in the scatter plot on the left. But in the second scatter plot on the right, we see a classic curvilinear relationship. But if you calculate a correlation coefficient with these same data, you would find a 0 correlation coefficient, the same as is indicated on both lines. And you see the red dots on the curvilinear relationship create the line that best represents the linear trend in the data, which is a flat line indicating no relationship. And we can see that this trend line for the curvilinear relationship would be similar to the trend line for our no relationship graph that is estimated by the red line on the left. So another problem or issue that can arise with correlation coefficients is that often outlying scores can either increase or decrease the value of a correlation coefficient because the coefficient is assessing a linear relationship, and a single point can either act as a point to fix a straight line to, or can pull the line away from an otherwise linear relationship. Let me share a personal example from one of my graduate students' research projects. That project looked at the relationship between the number of hours a person is trained in a new job and their level of satisfaction. The student strongly anticipated a strong positive relationship between these two variables, but I wasn't convinced. After analyzing the data, the student came back and said they found a correlation of 0.6, which was not what I had experienced. So I asked the student to graph those data, and they produced this scatter plot on the left. Look at that data point in the upper right-hand corner. That's really called an outlier because it is out of the normal range of data. I asked the student if that data point was valid, and we determined that it was. There was that one person who had 30 hours of training and reported high levels of employee satisfaction. So what's the problem? Well, if we had tested individuals between 15 and 30 hours, and if that trend had followed what we see here as a trend, I think you can visually agree that we would have a moderate relationship, and the correlation as calculated would appropriately describe the relationship. But look what happens when you take out that outlier. The strength of that relationship drops dramatically, and in fact, it becomes negative. I call this graph the revenge of Dr. Coughlin, or I was right after all. So you might ask, what do you do in this situation? Good question. Well, you need to describe the relationship with and without the outlier. You must conclude that there is no linear relationship between the number of hours of training and employee satisfaction with employees who are trained between 0 and 15 hours. And we cannot extrapolate or go beyond the range of the data that we have. To do that, we would need to go back and focus on employees with training between 15 and 30 or 35 hours, and then add that to our data set to see if that same trend can continue. It's also important to note that outliers can also decrease the relationship. Here we see an example with an outlier that is making a strong relationship weak. But removing that outlying point makes that relationship stronger. However, if that outlier is a valid data point, then we could have a curvilinear relationship that is occurring. So let's pause a minute here to ask some questions. Ask and answer some questions. How are we doing up there, Nina?
Great, we have a couple of questions. So, can you talk a little bit more about why we don't need to be able to determine causation from our research?
Sure. To me, it's because the presence of the relationship is enough to allow us to take action. Because the presence of that relationship really gives us enough empirical evidence to say that students would benefit from strengthening their skills, or students that improve their study habits or students that have improved their study habits and find a relationship can improve their GPA, or whatever the relationship is that you found that was positive. In other words, empirical evidence is actionable in and of itself because it provides evidence of being able to improve student performance. And I don't have to go as far as to prove the causation, because ultimately I'm only after improved performance.
Perfect. So Al asks, again, talking about causation, how can you say that smoking cigarettes causes cancer?
To me, you can't. You can say that there's a strong relationship between, as many studies have shown, between cigarette smoking and cancer. But to me, because with just a correlation coefficient, I can't imply causality. To be able to meet that standard of applying causality, I would have to do some kind of an experimental design, which to me would sort of be unethical, because I would have to make somebody smoke cigarettes. And that's certainly not something I'd want somebody to do. But I go back to my same point, which isn't there strong enough evidence that smoking cigarettes is related to acquiring cancer that should be a motivational factor enough for someone to want to quit. But I guess that's a whole other course in psychology, isn't it? A little bit of cognitive dissonance thrown in.
Yeah, definitely. So a couple more questions. So Kristen would like to know, can you speak a little bit about a rule of thumb for sample size to handle sensitivity to outliers?
Correlation coefficients are definitely one of those statistics that fall in my realm of the more the merrier, because you are trying to measure a relationship, and the more observations that you have, the stronger the greater your statistical power is going to be. I don't think that in most institutional research studies that we have much problem with sample size issues, because we are using either large sample sizes from our survey data or large sample sizes from our institutional data. Where I worry about sample sizes with some of my faculty colleagues who are doing research on their own and are collecting smaller sample sizes that are, under 100. I really worry about whether that sample is representative of the population. So to me, it also goes back a lot to how representative is that sample of the larger population. So I'm not going to give you a hard and fast number of how many it has to be. I want you to be more critical of the sample that you're looking at.
Great. Julie would like to know, how do you determine if an outlier is valid or when it should be removed?
Yeah, you actually have to dig down into your data and find out. So I literally asked the student to go back to that data that he had drawn, and to verify, because the data was identifiable, I asked the student to go back and identify the individual, and to actually go back and first verify with the employer that they had done that many hours of training. And secondarily, I asked him to go back and rescore his test, because literally the individual, the participant, was at almost the top of that scale. So we did both things, and then I thought we had enough evidence to assume that the data was valid. I realized that in some cases in institutional research, that can be easier to get to the bottom of than in other cases. At some particular point in time, you really have to make some sort of reasoned decisions about what might be reasonable and what might not be.
Nice. We're going to take maybe 2 more questions. This next question is from Kelly. She asks, can you speak more on using time as a variable and its effect on correlation?
Sure. The real issue that I see with time data is also similar to some of those issues that you can see with Likert scales that are reverse scored. Basically, what's happening is with time data, a lower score is a better score. So when a lower score is a better score compared to another scale where a higher score is a better score, the relationship is still really positive, isn't it? Because they're both going in the direction that you want. So the relationship comes out to be a negative one, but it's a function of the scoring. I've also seen that when I've tried to correlate some scaled scores on some from some instruments, and I've used positively worded items and negatively worded items. Well, of course, the positively and negatively worded items, if they're working together in the same way, they should be negatively related. So it's really a function of, does the direction of the outcome indicate that both are improving in the same direction? That's really a positive relationship. Whereas time data, because of its nature of doing something faster is better, makes that to be a negative relationship. Does that help?
Excellent. Actually, we have two more questions. So Kevin would like to know, is there a way to test correlation across many continuous variables, or would you just repeat this test for each combination of two variables?
Sure. Well, that goes back to where I said that correlation is a bivariate statistic, which means that the correlation coefficient as a statistic can only measure the relationship between a pair of variables. What you can do, of course, and we'll see this in our case study, is we're going to look at lots of these correlations to see how variables are interrelated to one another. And of course, that then expands to a little bit beyond our discussion today of trying to create that predictive model where we might want to use multiple variables to predict another outcome, which would be a form of multiple regression, multiple linear regression.
Perfect. And then the last questions for me. So earlier you mentioned that correlation was both a descriptive and an inferential statistic. Can you talk a little bit more about that?
Yeah, thanks, Darlene. It's kind of like you read my mind there, because it's really where we're going with our case study. The idea is correlation as a statistic, as we just talked about in terms of these descriptive statistics, stands alone because it describes the relationship. But sometimes, as we talked about in the other webinars, descriptive statistics aren't enough because we want to be able to use that sample data to draw inferences and make conclusions back to the larger population. So that's why and how descriptive statistics, the correlation coefficient, can be used as an inferential stat to test the significance of that relationship. So maybe we could use that as a springboard into our discussion of our case study.
Perfect. Yeah, let's advance.
Okay. So let's see if we can give this a try. We will explore a potential question posed at our hypothetical institution, as we have in our other two webinars. And as we discussed in those webinars, our institution has undergone a strategic initiative to increase the percentage of students of color to 25% by the fall of 2020. As we seek to reach this goal, a Vice President for Academic Affairs and a Vice President for Student Affairs would like to know more about our growing population of African American and Latinx students, specifically with regard to their readiness for college. So for the past 2 years, we've been distributing the College Student Readiness Inventory, which is designed to identify at-risk incoming students using non-cognitive indicators of success. It provides several indicators that are useful to explore, like social engagement, study habits, verbal competence, receptivity to academic assistance, the student's level of academic stress, dropout proneness, and educational stress. These are data that can help us answer the provost and vice president of student affairs questions. So we want to continue to explore our population of African American and Latinx students. We also want to continue to measure academic success by using first semester GPA as a proxy for academic performance. Thus, we can further refine our research question to explore, is there a relationship between first semester GPA of African American and Latinx first-year students and their scores on the subscales from the College Readiness Survey? So, descriptive statistics to the rescue, and back we go to the descriptive statistics that we ran in webinar 2. And here we identified two groups of students, African American and Latinx students, and all other students. And we identified that there was a significant mean difference in the average GPA scores of the two groups of students. It's important to note that moving forward, our new data file will only include the 135 African American and Latinx students, since they are the focus of this new research question. We certainly need to drill down into that data and run the descriptive statistics for the other variables. This next table shows the descriptive statistics on all these variables for African American and Latinx students. We see the same mean and standard deviation for the first semester GPA, which was 2.58 plus and minus 0.55. And we see that the scales from the readiness inventory are measured in percentiles. This makes the interpretation of these scales easier, since they're based out of a total of 100. And the higher the value, the more the student demonstrates that trait. From our descriptive statistics, we're concerned that one of the highest scales is academic stress. But we're encouraged that students also demonstrate a higher level of receptivity to academic assistance. And their study habits were fairly high. While these descriptive statistics are interesting, we need to explore the relationship between these variables. So next, we calculate the correlation coefficients. And its output is what's called a correlation matrix. The correlation matrix is a table showing the relationship between the correlations of all of our variables. As you scan this table, you'll see that each variable is listed down the rows and across the columns. The data in the table shows the correlation coefficients between any two variables. Down the diagonal of the matrix, you'll see a correlation coefficient of 1.0, which is the correlation of the variable with itself. And that's because we have actually calculated the relationship of the variable to itself. And not surprisingly, that's a perfect relationship. Or as I'm fond of saying, unlike people, variables don't argue with themselves. Another thing to point out is because each variable is correlated with every other variable, the matrix is symmetric, meaning the top of the matrix is a mirror image or a repeat of the bottom of the matrix. Notice that the correlation of study habits with first semester GPA is the same as the correlation between first semester GPA and study habits, because again, it is that same or shared relationship. Let's look closer at the relationship between first semester GPA and study habits. Here we see the correlation matrix between these two variables. The correlation is a positive 0.286, which is a moderate relationship. We also see from the asterisk that the relationship is significant. In webinar 1 and 2, remember, we discussed significance and learned that it represents the probability of error. In this case, it's the probability of error in stating that a significant relationship exists between these two variables. Here we see that the significance level is 0.001, which allows me to conclude, because it is less than 0.05, it allows me to conclude that a positive relationship exists between these two variables. That's a good outcome for our institution and our study. So as we might expect, as a student's study habits increase, so does their GPA. Given this relationship, we could identify students with lower study habit skills and work with them to improve those habits with the expectation that their GPA would follow the same trend and would improve. Let's go back to our larger correlation matrix to look at other interesting relationships between the factors on our college readiness survey. Not surprisingly, academic stress was positively related to a similar scale called educational stress. Other scales provide examples of some interesting negative relationships that could be of potential use to our academic support staff. For example, we found strong negative relationships between study habits and academic and educational stress. This tells us that as the study habits of an African American or Latinx student increases, their academic and educational stress decreases. This could be another important factor for our academic success people. Well, we can't say that increasing study habits will cause these stressors to, we can't say that they are related and identified. I'm sorry, let me back up a minute. This tells us that the study habits of African American and Latinx students increase, their academic and educational stress decreases. This could be another important factor for our academic success people. While we can't say that increasing their study habits will cause these stressors to decrease, we can say that they are related. And identifying students with lower study habits and helping them to increase those habits can lead to reducing those stressors. So 2 other moderate negative correlations were found between these scales for this population of students. The first is between study habits and dropout proneness. The higher the study habits are, the smaller the dropout proneness will become. This finding also reinforces the importance of improving study habits of African American and Latinx students who report lower scores on the scale. And the second is between verbal confidence and academic stress. Here we find that as a student's verbal confidence increases, then their academic stress decreases. This could be valuable information, again, to share with our academic support colleagues. And yes, while we need to be careful not to imply causality, correlation is a very valuable tool because it provides actionable steps that can be used to help our students. Now, we did diverge a bit from our research question as we explored the correlations between the subscales and how we could use that information. Let's go back to our main research question, which was to explore the relationships between these subscales in our first semester grade point average. Here is a correlation matrix that shows the 3 significant relationships between first semester GPA and these subscales. So what did we find here? Well, we found that for African American and Latinx students, we found a significant positive correlation between first semester GPA and the study habits, which we discussed earlier. And we also found 2 negative relationships between first semester GPA and dropout proneness and educational stress. The logical conclusions from these data are as dropout proneness and educational stress decreases, then the first semester GPAs rise. Or, as first semester GPAs rise, a student's propensity for dropout proneness and educational stress decrease. Because remember, it's that shared relationship. So increasing student success then, we should advocate that our academic support team use these data to identify and work with students who match these profiles. Certainly, this will lead us to more questions. But again, research often does. It raises as many questions as it answers. So I'm sure that there will be more questions that will arise. For example, we did not look at the ability of these variables to predict first semester GPA. That would be the next logical extension of our analysis and would use a different statistical procedure that we spoke about earlier, multiple linear regression. Also, we only explored these relationships for African American and Latinx students and did not look at whether these relationships are similar or different for all other students. We could explore this by comparing the correlations for the two groups, or we could test mean differences between African American and Latinx students and all other students on each of the subscales of the college readiness inventory, as we did with GPA. Questions such as these really could be important for us to examine if we wish to explore how we can reach our institutional goal of increasing the percentage of students of color to 25% by the fall of 2020. And as we've seen, answering these questions helps us to support student success. So let me pause again for some questions and some discussion, Darlene.
Excellent. Just to remind you, if you want to ask a question of Mary Ann, just expand that questions box in the GoToWebinar control panel, type in your questions, hit send, and it'll appear on my side of monitors. So a couple questions. So Kevin asked, what does it mean if the Pearson correlation coefficient is near 0, but the significance value is also near 0?
Well, I would argue that that shouldn't happen all that often because the strength of the relationship is what is being tested. But what I would answer to Kevin is something that I probably should have pointed out earlier, which is that when we ran the test of significance in our testing, what we're actually testing is whether or not that correlation coefficient is significantly equal to 0, or is it different from 0? So literally that's the same as testing whether or not there's a relationship that exists between the variables. And so with large sample sizes, and this may be where Kevin's question is coming from, with large sample sizes, small correlations such as 0.2, and even 0.18 or 1.5 can be statistically significant. And it gets back to our discussion we had in webinars 1 and 2 about the difference between statistical significance and practical significance. And here I would add something that would come up in the discussion as we explore multiple linear regression, which is to better understand that if I had a small or low correlation that was statistically significant, I would calculate what's called the R-squared. And it's very simple to calculate because, as the name implies, it simply takes the correlation coefficient, the R value, and squares it. So if I have a correlation of 0.24, my R squared would be 0.12 of that. So I would be able to explain approximately 12% of the variance in that shared relationship from each variable. So using the R squared value can help you to explain that. I would also say to not dismiss small R squared values, because sometimes it is important to be able to explain 7% of the variability. It can be a significant portion of the variability that you're explaining. But what that does then say is it doesn't explain all of the variability in the scores. So it's not going to cover a robust set of cases. Does that make sense?
Absolutely. Not yet, but hopefully he'll type in a follow-up question if he has one. Maria asks, Please give an example of how you could report the correlation coefficient in a report and in a presentation. How do you do that in terms that are not so technical?
Yeah, sure. I do talk about the value of correlation coefficient. And I wouldn't be afraid to say that the correlation between these two variables was 0.3 and it was a moderate relationship. I tend to label correlations that are significant, that range in the 0.2 to 0.3 value as moderate relationships. As they get up into 0.5 and 0.6, as you saw in my demonstrations, I started to call them stronger relationships. And you can use vague terms to talk about what's a moderate, what's a strong. And then what I do is if people ask me what the value was, I share with it, and I talk about the ranges that I have used to create small, medium, and large.
Do you have, I'm going to do a follow-up question. Do you have any problems or difficulties explaining just the concept of correlation to an audience that may not be well-versed in that area?
I use the language that I try to use fairly consistently throughout my presentation, which is when it's a positive relationship, I talk about as this increases, this other variable also increases. As this variable decreases, this other variable increases for a negative. And that's really very visually easy to describe. And again, I think the scatter plots themselves, when they display nice, strong trends, can be a good visual to include in a report.
Very good. Shalinda asks, and forgive me if I didn't pronounce that right, how do you adjust for outliers when you cannot go back and validate responses given by an individual, like a student?
What I tend to do in that case is exactly what I did in my data set. I pull the outlier out of the data and I run the correlation coefficient again. If the correlation coefficient drops dramatically or goes from being significant to non-significant, then I have to report the data without that outlier. Because it's simply too much to think that the data would follow the same trend across this range of data that I don't have. So I would much rather, especially in correlation, to err on the side of removing the outlier and reporting the data without it. And most of the time, we have very strong, robust data sets, and removing a few outlying cases, you still have a great deal of statistical power.
Nice.
Err on the side of taking
Jean would like to know, what is an example of when you removed an outlier and the relationship was weaker or the relationship was stronger?
Sure. The classic example where I had to remove it and the relationship became much weaker was that was the real life. That was actually real live data from a student study that I worked with. It was a student's master's thesis. So that was the clearest example of when it truly made a difference. And again, I think many of the times in removing these outliers, either it doesn't change the data because my data file is so big and so robust that it doesn't change the outcome, or it's pretty clear that either that data was bad or I hadn't tested enough cases to assume that that trend was going to continue on the same path.
Excellent. So you definitely don't want to remove an outlier and have a change. That's not what you want to see.
If you remove an outlier and it goes from being significant to non-significant, you must report the data as being non-significant for the range of data that you have.
Good. Margie would like to know, if your data is nominal, does this change your interpretation? You would not have a linear plot.
Right. If this data was nominal, I would not be running the correlation coefficient that I talked about today at all. I would be back doing the chi-square that we talked about in webinar number 1, or the t-test that we talked about in webinar number 2. In other words, what you're really saying is that the research question has changed. Because with nominal data, even though sometimes we talk about wanting to know the relationship between one's gender and one's performance on a particular test, that's not the question we're asking. We're asking, do males and females differ on this outcome? And that's a comparative question. So I would say that if you're thinking about a nominal variable, you want to go back, like we've tried to emphasize here, and be sure that you've got the right question. And again, so for here, if I don't have at least interval or ratio data here, I would not be running this Pearson correlation coefficient that I ran. If you have a bunch of Likert scales that you want to correlate, there is a non-parametric statistic called the Spearman rank order row that can be run that tells you the relationship between Likert scales.
Nice, thank you so much. Anita would like to know, have you had or have you seen a curvilinear relationship that made sense in institutional research?
The closest one that I've seen was actually part of I was working with our Academic Success Center data, and they were trying to work with students on test anxiety and performance. And we were analyzing some of the data between the students' level of reported stress on exams and their scores on exams. And we really did see that classic inverted U theory in our data, where students with a little bit of stress helped them, to perform, but that once you had sort of reached that optimal level of stress, that too much stress just sort of made the curve drop right back down. So the most realistic one I've seen is the relationship between anxiety and performance on exams, test anxiety and performance.
Good, thank you so much for that. A question from me. You mentioned earlier that your IR colleagues should use research designs like comparative and correlational more than they actually do. Why do you think they don't?
I think it's a combination of different things, Darlena. Sometimes I think it has to do with the individual's own comfort level with understanding of research design and statistics. And I often get many emails and questions from colleagues of, is this the right design? Am I running this right stat? And sort of because there's a real inherent comfort level in IR professionals with data analysis and descriptive statistics that we then tend to over-rely on them. And again, so sometimes I think it's expertise. Sometimes I think it's access to statistical software. And other times, I truly believe it's lack of the additional time that drilling into the data like this actually takes in order to run the right analysis, do the appropriate steps to do it. I think the time pressure on us to get an answer to a decision maker and just increasingly force the hand away from being able to have the time to complete these analyses.
I'm sure you'd have a lot of people that would agree with you. So let's go ahead and move on and wrap this.
Okay. Sure. So again, as I've tried to mention over the past 2 webinars, there really are many resources and references for basic stats. Don't be afraid to Google a statistical term. You'll find many great references out there. Stick to some of the academic ones. Use your good information literacy skills with interpreting that, but there's some great, everything from Khan Academy to other video tutorials and variety of stats textbooks. If you want resources specifically on the stats. But when you want to try to find them on the application of statistics to IR, you really will find far fewer. Specifically, the most closely aligned with the material that I presented in this webinar series is that classic reference that I wrote with my former colleague, Marian Pagano, that is available in PDF format to AIR members in our e-library. The second reference, again, people often ask me for what's my favorite, social science stats textbook. The Triola version is really one of my favorites. Of course, there are many others out there. So I also hope that you found this webinar series to be a valuable resource to you as well. And as Darlene has mentioned, you can certainly download these slides as part of your materials. I really do want to thank you for your participation in this webinar series. Personally, I was really overwhelmed by the interest in this webinar series. It's been great to see such participation as part of this series. I also want to say that each one of you adds greatly to the quality of the webinars with your questions. And please do keep an eye out for other webinars on research design and statistics. You're certainly showed to the association that this is something that you find valuable and helpful. And of course, if you're interested in attending other webinars hosted by AIR, there's much more information on our website. So let me turn this back over to you, Darlena, as we wrap up.
Thank you so much. This was incredibly helpful. Participants, don't forget that you'll be receiving an email from me with a link to a survey to give us feedback. And as Marianne said, we have a lot of other educational opportunities available that we're developing every day, it seems like. And again, thank you so much for attending. This was really, really great, and I hope you have a great rest of your day and your week. Thank you so much.
Our department has.
Bye, all.
Okay, bye. We have purchased a few more AIR webinars throughout this semester, so we're going to send you guys the email, and you also can find the schedule on DevelopU. Another place to find the information is go to IER website, and we have IER events created there. So we're going to have projection, webinar, and the other ones are going to talk about the survey design. So welcome you guys come back. Thank you so much.
Will you have any Qualtrics?
We do, yes. Oh, Qualtrics training. We don't. AIR does not have Qualtrics training. Well, I know one of the department used to take over this responsibility, but they are no longer exist. So.
Well, I know David Giles used to teach it, and
yes.
I've been to his
class
training over there.
Yeah, I know he went to the Qualtrics Summit to get more educated, but right now I really don't know who would be the good person to go to.
Okay, but I still will come to you. Other things y'all have on that list too.
We could. We actually talked about, one time I did mention to Dr. Gibson, because I got people asking about Qualtrics. The idea is if we could get one of the Qualtrics person come over here to train the campus for free, that would be very ideal. But that's something we talked about. We have not have a very detailed plan. But yes, if you do have any questions, I'll do my best to help you.
Well, thank you.
You're
Well, if you
welcome.
see Shonda anytime soon, tell her Robert Wolf said hello.
Yes, absolutely. Thank you.
Appreciate it.